Okay, so you can see the difference here. We have the Stay Bright number 8 with the Stay Clean Flux here. We have the regular Dynaflow Phos Copper sticks with nitrogen purge, without nitrogen purge, and your 45% silver solder with Stay Sil Flux on a copper to steel joint. Hello and welcome back to the shop, and this video is the beginner video that went out, and this is going to be all about brazing versus soft soldering, when you should use both, how I use them, and everything else. So before we get into that, I just want to thank everybody that wished me a happy birthday last week on Facebook. I think I thanked all you guys in the post, but I may have missed somebody here and there, so I just want to say thank you. And like I said, we're doing soldering and brazing. Now, this is all going to be my experience. Other people's experience may be differently. Some people may disagree with what I'm telling you, which is perfectly fine. I've been working in this trade, in refrigeration trade, for 16 years now, pretty much since I was 16 years old. And I'm 32 now, so I've been doing this for 16 years, and I've been working for my company for 15 years. So this is going off all my experience. Now, what I work on is light commercial units, so walk-in coolers, usually restaurants and stuff like that. Walk-in coolers, walk-in freezers, rooftop units, usually up to 20-25 tons. Reach-in coolers, reach-in freezers, that sort of thing. We also do have units and have installed units that are 410A, which is the newer refrigerant that has since replaced R22 since they've gone with the EPA phase out, and that's it. So what we're going to do is we're going to break this down into a few sections, and the first thing we're just going to talk about is just the copper, and then we'll talk about the actual, well, first we'll talk about the products, then we'll talk about the actual tubing, and then joint prep and things like that, and we'll go through, we're going to soft solder using the soft solder I'm going to show you. We're going to braze using both a Phos copper stick and also 45% silver, which is known as silver soldering more than silver brazing, kind of interchangeable on that type. What to do, what not to do, and things like that. So let's home in on the bench here, and we'll go through the 3 different products that we're going to use to join the pipe. Okay, so first we're going to kind of focus on the soft solders, and these are the 2 that I use. And like I said, everything here is Harris branded products, and this is Bridget soft solder and Stay Bright number 8. The number 8 is important, and I'll show you. This Bridget stuff, I use this on drain lines and water fittings, like if I need to connect an ice machine to the water line or whatever, solder flannel on for a water line for an ice machine. This is a solder that will be used. And the reason for that, the main reason for that is that this solder here is a lot cheaper than this Stay Bright solder. And the reason is this contains silver. It's silver bearing solder, as you can read right there. Now, there's a huge debate on whether soft solder should be used in refrigeration equipment or not. Okay, I'm here to tell you that it can be used if you use this product. And I'm not being a shill for Harris products, it's just I really like this solder, and I haven't had an issue with it, and I have with some other ones in the past on refrigeration equipment. So now what this is silver bearing solder. Now there's 2 Stay Brights, Stay Bright labeled products that Harris puts out. One of them is just called Stay Bright, and then there's another one called Stay Bright number 8. And the main difference between them is the amount of silver content. And I have the spec sheets printed out right here. I came prepared for class. So Stay Bright, just the Stay Bright, not the number 8, has 3.4 to 3.8% silver, and the rest is tin. Stay Bright number 8 has 5.5 to 6% silver, and the rest is tin. And the biggest difference between them is the melting point. Stay Bright, just the plain old Stay Bright, has a solid and liquid melting point of 430 degrees, meaning that it melts into a nice liquid form at 430 degrees. It has a permanent melting point. Well, Stay Bright number 8 here has a temperature range. So the solid form of it, which is 430 degrees. So it will start to melt at 430 degrees and won't become completely liquid until 535 degrees. So what that means is you can feather your flame and get this to bridge a gap on a loose fitting pipe. Now, the downfall with this is that, and which is why I think personally that brazing is used more in the refrigeration setting. The downfall with this is you have to clean your pipes. So you have to clean your fittings with a wire brush, you have to clean the outside of your pipe with the sandcloth, and you have to use a flux. And this is an acid-based resin flux. It's a paste. Okay? Now you'll hear people say, never use flux in the system, it'll get in the system and it'll ruin it. You have to use a shitload of flux to do that. You'll see the amount that I'm going to be putting on these joints. It's not going to get into the system, and it's not going to cause a problem unless you really glop it in there. And I'll show you one of the biggest mistakes that people make with using flux and how it can get into the system. Now, the other thing is you'll hear people say, yeah, you can use soft solder, but you can only use it on the suction line, which is the low pressure side of the system, which, let's say on a normal R22 air conditioner, your suction pressure is around 68, 70 psi. On a 410A system, I think it's, off the top of my head, it's 100 and something, 125, 140, something like that. I can't remember, not looking at the PT chart right in my hand, but somewhere around there, okay? Your discharge, now your high side, your liquid line, will be, on a normal 22, will be about 2 1/4 to 250, and your 410A will be running up in the 3s somewhere. Okay, now just looking to see what the. All right, so we have a tensile strength on Stay Bright of 14,000 psi and a shear strength of 10,000 psi. Okay, so we're not going to pop a joint. As far as PSI goes. The other thing that you'll hear people say is, well, maybe you can use it on the liquid line, but guess what? You can't use it on the discharge line of the compressor, which is the line coming right out of the compressor, which it gets hot as hell, and you can really burn yourself off of it. Well, I'm here to tell you that you can, because look at your compressor's manufacturing specs. Okay, Copeland off the top of my head even says in their manuals and everything else that the discharge line of a compressor should not get above 225 degrees. Not to say that it never does. It can with either something wrong with the system, low charge, things like that. It can be above that. But they say that normal operating pressures, operating temperature is 225 degrees, okay? So let's even up that to 300 degrees, okay? We're having a bad day with the compressor. So 300 degrees, in my opinion, you'll be cooking your compressor way before you fail a joint. This starts to melt at 430 degrees. So we're still 130 degrees off from melting this solder. Now, everybody else will say, some people say, vibration plays a part in that. That it can wreck the joint from vibration, and the joint will, the solder will break. It won't. Everything in the refrigeration system vibrates. There's vibration dampeners in the system. The compressor's on little rubber feet to take most of the vibration out of the system. If you have a bigger compressor like a semi, that thing's on springs floating around there, and that usually has a vibration eliminator and everything else. Vibration isn't going to affect this. I personally, I mean, I've seen this leak before, but I've also seen braze joints leak before, and usually it's an issue of the actual bonding of the metal. Or a joint issue. It has nothing to do with the solder itself being weakened. And where this really, really shines is doing sensitive parts
I don't happen to have one down here with me, but I have a doing sensitive parts like valves and reversing valves and expansion valves. You can kill these if you put too much heat into them, and you have to put a lot of heat to braze these. And then, you know, you have to wrap it around like crazy with towels and everything else to keep it cool. But you're only heating these two joints here to 400 degrees instead of 1500 degrees by using soft solder. So this is a very, very good product, and it has a lot of benefits and not much detriment. I mean, I think, like I said, the reason why people braze is because you don't need to clean. There's no joint prep. You just put the pipe together, braze it. People think that they're saving time, and people don't like to clean the copper. But I'll be honest with you, even when I braze, I clean the copper. But that's besides the fact. But I think that's the biggest thing as to why people shy away from this. But like I said, I have never had an issue with it, and we're going to show you a bunch of benefits for this without much detriment to it. Okay, so the next item up for bids here is Harris Dynaflow Floss Copper Sticks, and this is your typical brazen rod. Now, I use the regular Floss Copper ones because they're cheaper. They have up to 15% silver bearing brazing rod, and they get quite expensive as to compare with this. But if you actually look up the specs on it, you can see that this is about 6% silver, and the other one, like I said, is 15% silver. But the temperature melting points are pretty much the same, and tensile strength and everything else is pretty much the same. And for this, it starts to melt at 1190 degrees, and it becomes completely liquid at 1470 degrees. So it starts to melt at 1200 degrees and turns completely liquid at 1500 degrees. Now, there's your biggest problem, is just the heat involved. And what happens is when you heat the copper up that high, it does two things, one beneficial thing and one not so beneficial thing. The beneficial thing is that the heat will actually clean the pipe. It'll actually burn all the impurities out of it, and this stuff is self-fluxing, requires no flux. The bad thing that happens is as soon as you pull that torch away, that copper immediately oxidizes and immediately gets this flaky skin on it. Now, that's happening on the outside of the part, but it's also happening on the inside of the part. And we don't want any of that garbage in our refrigeration system. So to use this properly, you have to flow nitrogen through your pipe to displace the oxygen, the air in the pipe, and to prevent that scale from building up on the inside. Now, not a lot of people do that. Some people do, some people don't. But I'm telling you right now, I have a lot of places, a lot of calls, and people don't do that. And you can see kind of here's an instance of a place where they didn't do that, and you can see the oxidization on the inside of that pipe as compared to something like this. It's not really a good example. You might not be able to see it in there. You see all the crud in there compared to this one? Alright, and we'll show an example of that. Now, where this stuff does shine is obviously if you have a previously brazed joint and you need to fix a leak, you would need to use this. Also, say you're unsweating a compressor and just wanted to sweat the compressor back in, you're going to unbraze the joint, heat it up, and pull the pipe out, and then rebraze it back in. But where I particularly find this useful is bridging gaps. Now, where are you going to find gaps in pipe? Well, I've noticed that sometimes you get really crappy fittings and loose fittings, and usually that's on the back of an evaporator coil where the suction and liquid line comes in. Like if you're replacing a coil, for some reason those swedge joints are just slightly too big, and the pipe likes to float in it. So what I like to do is braze that one joint and soft solder the rest. Also, usually sometimes the copper P-traps, the preformed P-traps, sometimes those fittings on the end, they're slightly oversized. I don't know if it's just a manufacturing thing. I mean, everything's made in China, so that could be it. But the other place that you're going to find gaps, where I use this a lot, is drain lines. Walk-in freezers and things like that have a drain line, and that drain line is wrapped with a heat tape. Sometimes the heat tape fails, or sometimes you get a clog down the drain and it backs up and it freezes and it bursts the pipe. Well, sometimes things are so tight in a walk-in because you have 9,000 racks everywhere. It's hard to get at the pipe to be able to cut a piece out, cut a piece out, make a new piece, put 2 couplings in, solder it back into place. So what you can actually do is squeeze it back down, and you'll have that little crack, and you can actually just braze right over it. And the good thing about that too is that's going to be the weakest point of the pipe. So if it ever does freeze up again, it's going to burst your braze joint, and it usually won't burst the pipe down someplace down the line. Now we'll show examples of bridging a gap with this, and how we need to use the nitrogen and everything else. Now the last piece here, and it comes in a roll, and this is just a piece here, and you can see it has a gold tinge to it, and this is silver solder. Even though it is brazing, it melts at roughly the same temperature as these phosphor copper sticks, but this needs flux. Even though it is a braze, it needs flux, and this is going to be that white paste flux. Alright, and you can see this bottle's ancient because I hardly ever use this. Now where you need to use this 45% silver stuff is when you're connecting copper to steel or steel to steel. Where you're going to find that in the refrigeration system? Well, you're going to find that on most service valves that bolt onto the compressor. I've always called these Rotolock fittings, but I'm pretty sure that's a proprietary name for Copeland's little fittings that go on there. But there's a threaded little boss on the compressor. These guys screw on there, and you can see it's all steel, and you have to put a piece of copper in there. So you have to use the silver solder to connect that joint. That's the only thing that will join copper to steel. Now here's the thing, why I call BS on people saying that this flux ruins the system. Well, this is also flux. This is acid based, and this you have to use when connecting this using the 45% silver rod. So what is the difference between using this in the system, which is perfectly accepted and acknowledged as the only way to do it, to using this on the system? I don't see a difference. So we'll show how to connect those up, and we'll go through all this and show some of the benefits and the detriments as we go. Now what I want to talk about real quick is the actual tubing. Now there are 3 types of tubing, K, L, and M. M is thinner walled plumbing tubing. L is, or ACR tubing, commonly called and referred to as that. That is the tubing that we use in the refrigeration trade, and that is thicker walled, and it's also nitrogen charged. It has a nitrogen holding charge in there if you buy it in a 20-foot length. Usually if you buy a 10-foot length, it's a 20-foot length that's cut in half. Also, that copper is made without any kind of release agent on when it's drawn through. So there's no wax, there's no powder or anything in there, there's no contaminants. It's a clean piece of pipe. And to show you, and then there's K tubing is really thick walled stuff for special applications. Probably won't run into that. But just to show you a little bit of the difference here, you can see the wall on that compared to, of course the piece is too thick to get it up to the camera. I don't know if you guys can see the difference in the wall thickness of this M-type tubing compared to the L here. Now another thing, when I'm talking sizes, I'm talking ACR sizes, okay? So my sizes are not plumbing sizes. Plumbers go by the inside diameter of the pipe, refrigeration guys go by the outside diameter of the pipe because we gotta be different. So this here is good old half-inch plumber's pipe, type M, right? My half-inch is that, okay? That's my 1/4 inch. That's my 3/8. That's my 1/2 inch. That's my 5/8. That's my 3/4. And that's my 7/8. Okay, so when I'm talking sizes, I'm talking this. Now, quick word about fittings. there are two types of fittings, two types of 90s. Not just street and regular, which here's a street 90, which has one swedge side, one not, so you can hook it into another swedge point. And here's a regular 90. But you have long sweep and short sweep. So here's a long sweep and here's your short sweep. For refrigeration, always use a long sweep. Granted, there are some places where you have to use a short sweep, you're getting in a crazy tight spot, but where possible, always use a long sweep. Couplings. There is a difference between couplings. This is a plumbing coupling. This is a refrigeration coupling. Now I know a lot of big box stores are starting to stock all this stuff and is actually starting to stock L tubing, but you can see the difference here. You see I have a line here that would separate the two ends of the pipe and not allow the pipe to push through. Alright, so that's what stops it, and you can see in there, you see that little bubble. So the pipe ends hit that whole ridge inside. The plumbing coupling, the only thing stopping the pipe from sliding all the way through are just these little indents here. Right? That's just a mark. This little indent here and this one here, that's actually paint. So that's the only thing holding, and you can kind of see it down in there. That's the only thing holding you from pushing the pipe all the way through. And this fitting is actually kind of filthy. Most of these fittings and these pieces of pipe are just cut-offs off of my extras. I usually keep little short sections like this in the truck for drain lines and things like that on units. So most of this copper that you're going to be seeing here is kind of dirty and not anything that I would be using on an actual system. Most of my pipe in my truck, it's all carried in a the longer lengths are carried in a tubing rack, and they're capped on both ends. But these are just short little pieces that have been kicking around in my bag and everything else. Okay, so now to get to one of my pet peeves. When you're connecting pipe and tubing, for the love of God, buy a fitting. Since you can bridge a gap with this stuff, what I see a lot of is, you know, somebody taking a piece of 1/4 inch and a piece of 3/8 like this and sleeving it over, and like an ass, taking a pair of limans and crimping the sucker down to fit. You know, doing one of those jobs there, and then brazing that and using that as that connection. I know a lot of you saying, no, they don't do that. Oh God, yeah, they do. If you look on my Facebook page, I have a crap load of pictures of people doing that. That is this is just the worst. The only place that is anywhere near acceptable, this here, let me zoom you out. This is a pencil dryer, cap tube dryer. Alright, this is cap tube here. You can see how small it is, right? Well, when you put it in here, that tubing here is way bigger than the cap tube. So you have to crimp and either braze or soft solder that. That's acceptable because you have no other choice. There's no fitting that's going to reduce down to a cap tube. Also, the same thing, usually when this event enters an evaporator, you use a little tab of like 3/8 copper. Of this here that you have to put it in and crimp and braze. You have no choice of doing that. That's fine. But to do it like this, they make reducers. Buy the reducer. Alright, so let me set up a couple of pieces over here that we're going to actually connect. And we'll do soft solder first, and then we'll do brazing, and then we'll do the silver soldering. And you can see 3 differences. We're actually going to braze 2 different joints on the brazing rod, with and without nitrogen, so you can see the difference in that. And I'll show you the setups I use for brazing. Okay, first thing first, let's talk about how to get the part hot enough to solder. Okay, so these are pretty much my basic equipment that I use. What we have is a MAP gas tank with this is a Turbo Torch TX504 head, and this is a dual fuel head. You can use this on MAP gas and propane. MAP gas is more expensive, but it does burn a little bit hotter, so this is pretty much what I use. And it's self-igniting, and you can adjust it. Also in the same vein, this is a Aoutomatic one. This is a little older. I've found that the Aoutomatic one, I actually have to change the striker inside this. It doesn't auto-ignite anymore. But this one actually burns a little hotter than the turbo torch version, but they both work equally well. Now you can braze with these. You can braze probably up to maybe 1/2 inch, maybe even 5/8 copper. Anything over that, it's really struggling, and you want something a little bit bigger like this. And this is a turbo torch. It's made by Victor Technologies. It's hooked up to a B tank. They also make a smaller tank, an M tank, which is smaller than this. These tanks are really, this one's, I mean, I don't know what the weight is on this, maybe 30 pounds or so, maybe more, but it's light enough to be able to carry on a roof with you. Now, yeah, large enough to get a decent amount of use out of. The M tanks, I've tried them. I just don't like the longevity of the gas, how long the tanks actually last. And what this is an air acetylene torch. So just like these guys here are air and MAP gas, this is air and acetylene. Okay, so there's no extra tank for oxyacetylene ring or anything like that. And what you have are different size tips, and these are two of the most common ones that I use here. Okay, this one here is, this one you see here is a number 11, and this guy here is a number 32. And the number 11 is good for soft solder. It's rated for soft solder from 1 inch to 2 inches, and brazing 7/8 to 1.5 inches. This big guy here is rated for soft solder 4 to 6 inches, and brazing 1.5 to 4 inch. Now, this is the smallest tip I own, and I use this for everything. I braze 3/8 with this, I braze 1/2 inch, I braze everything with this, and it works perfectly fine. You just have to, you know, adjust your heat level, pull it off. Now the way that these work is, you can see you get a little quick connect coupling on here, and they snap right into place. You have a regulator here, but you want to run these full open. You want to run them all the way open all the time. Same thing with this little regulator here. You want this cranked in all the time. You can see it up here, just buried. You want these things screaming. They're loud, but they're good. I use these for soft soldering when I can't get the whole MAP gas tank in there. So if I'm working on like a low boy reach in, I got to crawl in the unit. These work really good, and that's the only time that I throttle down the flame on these is with the soft soldering. If you throttle it down too much, you'll see that blue flame start to inch into inside the pipe here, inside the actual tip of the torch, and the tip of the torch will get super hot, start glowing red. You want that nice little rosebud flame, you want that out away from the tip of the torch there. And like I said, these work really, really good. And they have much smaller sizes, and I think this is one of the largest. Not sure they go much larger than this. Anything larger than this you probably want. I mean, if you're trying to braze something that's over 4 inches, you're probably going to want an oxyacetylene rig or something like that anyway, because this does suck down some gas when you're using it. And those are the basic equipment that I use to soft solder. Now they do make I believe it's Aoutomatic makes a wand version of this. It's not self-starting, but it has the regulator that screws right into the top of the MAP gas tank, and you have a hose with a wand so you can get into tighter areas. I tried it out, and it works fine. I just didn't like the self-starting feature. I just like pressing the trigger and having it light up. So what we're going to do first is we're going to soft solder. I'm going to show you the process of going through that soft solder and what we come out with as a joint. Okay, so we're going to connect these two pieces of 7/8 pipe here with a coupling. Now we're using soft solder and a flux, but we need to clean the pipe. And the way we do that is using some sand screen. Now you don't want to use sand cloth with stuff that just looks like regular aramid cloth, like a strip of sandpaper. The reason why is that's way more friable than this stuff is, and that kind of sand stuff tends to go down the pipe. This stays intact a lot more, and it doesn't get nearly as much garbage in the pipe. And if you're careful, you won't get anything in there. So what you want to do is, one of the ways to pretty much minimize and eliminate that is when you sand these, sand it at an angle down. Don't sand it up like this and have any of the crap go in the pipe. And we only need enough clean to cover the coupling and maybe about an 1/8 inch or so. So when you look at it, you want basically the width of this piece of sandcloth sanded. Is what I usually go by. And the easiest way to do it is just to grab the pipe and twist your hand around it. It takes 2 seconds. And there you go. That's all you need. Now that step you get to skip, or this step here, you get to skip if you're brazing. But you can see it doesn't take that much time to clean up a nasty looking piece of pipe to get ready to solder. Now this is a coupling. We need the inside of this clean, but also what you want to do is give the outside of it a quick clean around the edge here, around the perimeter, and go just a little bit around the front edge. Well, why do you want to do that? Well, that helps you out on the days that you had too much coffee and you're a little shaky with the solder. If you hit this side, if it's clean, it'll roll into the joint and get sucked in. If it's dirty and you hit the outside of the pipe by accident, it's just going to roll off. So it just helps a little bit. And then take your wire brush and just give the inside a quick little twist on both sides. Until it's clean. And there you go, you can see the inside of that is nice and clean. So now we want to apply the flux. Now here's where people screw up, and where I think the idea that flux contamination in the system, flux contaminates the system. What you want to do, only flux the actual tubing, the outside of the tubing, and that's it. And you don't need that much. You don't need to glop it on. All you need is a slim coat, slim skim coat. You're barely even perceptible. That's all you need. That's it. If you have any glops, what I see a lot of people do is they'll take it out. Let me bury this and screw it back in. So here's your flux. They'll plop it out. You see that big glob on there? They'll start going at it, start putting the flux on there, and get something looking like that. No need for that. Let me grab a rag actually. So I just made sure that I got all that cleaned off. So you don't even need that much on the brush. You don't need to load the brush at all. All you need is a nice little coat on the brush and a nice little skim coat on your pipe. And now you don't want to go over the edge. And the biggest thing that I see a lot of people doing, and plumbers do this a lot, I don't mean to pick on plumbers, but I've seen a lot of plumbers do this, is they'll take the brush and they'll flux the fitting also. Don't do that, because then you will get the flux in the system. And now when you put it together, pop it in place there, pop it in place here. You can see you got a little ridge of flux that got squeezed out, perfectly fine. When you heat that up, that'll melt right over it and give you a nice little area for that solder to hit. So we're just going to put this in the vise to stabilize it. Now the other thing that you're going to want too is do yourself a favor and get yourself a wet cloth. Well, what's the wet cloth for? Again, picking on plumbers, I know. A lot of plumbers I see, not every plumber that I've ever seen, but a lot of plumbers will solder, and before the solder is hard, they'll take the wet cloth and wipe it and smear the solder. You don't want to do that. Your biggest enemy in refrigeration is moisture. You don't want any moisture contamination in the pipe. So you don't want to wipe down the pipe when that solder is in liquid form. What you want to do is let the pipe cool, let that harden up, give it a minute or so, and then wipe it down. You want to get this flux off when you're done. The reason being, if you leave that flux on here, it'll start to oxidize the copper pipe and turn it green. So you want that off. So when you use your solder, easiest way, don't use it straight like this. Grab about a 6-inch piece, 5-6-inch piece, bend it down like that, make like an L with it, and this will allow you to get the top and underneath really easy without having your hand up underneath like this and getting a solder drip on it. And when you heat the pipe, what you want to do, which is another thing that I see a lot of people screwing up on, you don't want to heat the joint. In other words, I'm going to zoom you in here. What you don't want to do is you don't want your flame just right here. You want your flame on the coupling. You want to heat the fitting and not the joint. The reason being is you get this heated up enough to where it melts the solder. When you touch the solder here, capillary action will wick this solder into place. And you'll see that when you'll be able to look down the pipe. It doesn't take much heat or much time to get this to melt. First you'll see this flux start to melt, and you'll see me touch the solder, and then that's it. Whoop. And heat from the bottom. So that way the heat rises and wraps around the top. On bigger pipes like this, you may need to give the top a little bit of a warm, and not that much. Alright, you see it just started melting. Hit it once, knock the nib off the bottom, joint's done. Joint's done. That's it. That's all you need for the solder. And just double check all the way around. If you need to add a little bit more in the corners, do that. But we're good. That's all you need. Sometimes it might fake you out because the flux may take some of the oxidization off the copper, cleaning the copper for the flux, and it may pop a black spot in it. But that's also where the rag comes in. When you clean it off, you'll be able to tell what's just a black spot and what's an actual gap. So I can tell right now we're completely cooled, or we're completely solid all the way around. And there you go, and that's it. I'd used a little bit more water than usual just so I can handle this directly after. But you can see, there's the joint, there's the bottom of the joint. You can see the little nubs on the bottom. That's perfectly normal and fine. You can see the top is nice all the way around. And we'll get a better close-up of these on the bench. Okay? Now let me just zoom you out here. A little toasty. So you can see we didn't damage anything with the pipe, we didn't discolor anything, and also the tempering is still, we didn't soften the pipe, so we didn't anneal the pipe at all. You can see I'm trying to bend it now. You can see it's still nice and solid. Now what we're going to do now is we're going to take probably a smaller piece, probably a piece of 3/4, and we're going to braise it. We're going to braise it twice. We're going to braise it with a nitrogen purge and without a nitrogen purge and see what happens. Okay, so we're actually going to use a piece of 7/8 and a 90. So I'm just trying to use up some of the crappy fittings that I had in the truck and you know, junk copper without having to cut a new piece or use a nice new fitting. I don't have any other 7/8 kind of trashy couplings, so we're going to use a 90. Now you can see how dirty that is. That's dirty copper. That's dirtier than usual. Me personally, even though I'm brazing, I still would give this a quick clean. It takes you 2 seconds, and let me tell you, it makes your joints look a hell of a lot better. Now you can see I have the 90 here, and I'm going to push in with all my strength, and I can't bend that 90, all right? I can't collapse it. So what we're going to do is we're going to add this into the vise here. Actually, what I should probably do is this way. Turn it to where you can see it. And we're going to zoom in here a bit. Okay, so now we're going to braise this, and we're going to be using our Foss copper sticks here. Now we don't have to clean it. What you're going to see with the flame is you're going to see wherever I put the flame, you're going to see a clean spot kind of appear. And now there is no nitrogen purge in this, and I'm going to show you what happens when you don't put a nitrogen through it. So you're going to see wherever I have the flame, you're going to see a nice clean spot happening. Now here's the thing. You have to get this red hot for this to flow. If you don't get this super hot and touch it, what will happen is it'll flow into the fitting perfectly fine and attach itself to the copper, but it won't flow all the way around. So a lot of times what you have to do, unlike you saw with the soft solder where I could just touch the top and it flowed right around, you may have to drag this around a little bit around the fitting to make sure you have it all, especially on the bottom. It tends to not want to stick where you on the bottom if you don't have it hot enough, just by gravity. So you need to make sure that you either get this hot enough so that this flows really nice, which you would have to get this super hot, like beyond red hot, or you can tell when it starts to melt, you can follow that joint all the way around with the stick. It's a little more involved process. So I'm going to be using the number 11 tip here, and we're going to light this up. We're going to get going. Alright, now you can see the flame right about here where that blue, and it's going to be your warmest part. Now you can see if I adjust this down too much and slow it down, you can see how that jumps back into this nozzle. Now this whole nozzle is getting hot. Alright? So you want it wide open. And just like before, shoot from the bottom up. And sometimes you have to swap it all around to get it nice and warmed up. I'm doing it on the top to show you. See this nice little clean spot? It's burning all the impurities off, which is why you can use this on really dirty copper. It's starting to get red hot. I don't know if you can tell or not. It's starting to get red there. So what we can do is touch it and you see it just flow. Now we're going to just work that around. There's one joint. And this stuff tends to want to follow where you're putting the flame. Okay, you can see that tweaked a little bit on me. That's because I didn't have it supported on this end. Normally you would have it supported. So now we're going to let this cool down enough to where I can handle it, and then I'll show you one of the bad parts about using this. So now you can see that was relatively dirty copper. I was able to braise it without cleaning anything, and which is also another benefit of it I didn't say over at the bench. If you have really, really dirty copper or pitted copper that you need to attach to or fix a leak on, sometimes your only choice is to braise. But
You saw how hot I had to get this and how much longer it seemed to take compared to, or to heat up compared to using the soft solder, even though I didn't have to clean it. So we're going to let this cool down, and then we'll show you one of the two of these. Okay, so this is cooled down a bit. It's still pretty hot, but I'm going to show you a couple of the detriments here of using brazing rod. So number one, you can see all this oxidization on the outside. If you don't flow nitrogen through that pipe as you're brazing it, that's going to be on the inside. You can see how flaky it is. See how that all came off? Alright, see it? That's all on the inside of the pipe. And I'll show you. Now, let me zoom out here a little bit. So, take something relatively clean here. This is still a little warm. Take this out. Ready? See all that? All this nasty ash stuff? All of that is going to end up in your system. See it there? All of that. Not what we want. Now here's another big detriment to using the brazing rod. Alright, you saw I couldn't bend this at all by hand. Now watch this. Alright, you anneal the pipe. You get all the strength out of the pipe when you do that. When you use brazing rod, when you heat it up that much. You're basically just annealing the hard copper. So your joint is strong. Your joint's fine. Your joint is nice and strong, but the copper around it has been weakened. Okay, so now you can see, here's the soft soldered joint. That ain't going anywhere. This one, alright, so even in the test that Harris conducted, you can see pictures of it. You can see, here's what the pipe that they used to test. It's wedged with another piece of pipe into it. Guess what failed? Not the joints, but the pipe. Why? Because the pipe is now weakened. Now, this is more subject to work hardening and vibration. Granted, you're not going to be doing this to it. It's more subject to damage from vibration by annealing the copper like that than this piece of hard drawn connected with that soft solder. Okay, so now we're going to do the same thing. We're actually going to use a smaller piece of pipe, 3/4 here, and we're going to flow nitrogen through it. And we're going to see that the inside doesn't get that nasty black scale. And you can see the inside of this pipe, and we'll show this on the bench too, has that scale build up in there that you can see. You can see it right there. Okay, so what I have right here now is a piece of 3/4, and I did clean the fitting because even when I braze, I usually just give it a quick clean. Just force a habit, and I think it makes everything move a lot faster. And you can see on the ground here I have a tank. That's my nitrogen tank, and I have it hooked up to a hose, and that hose is inside the pipe. And what we're going to do is we're going to trickle some nitrogen through here, and we're going to braze this and see how much of a difference that is. Now the problem with doing that is what happens when this is your last joint. You have to have a place for that nitrogen to escape. So you have to be aware that you have to be open somewhere on the other end. Usually the evaporator coils and stuff will have a gauge port, something that you can hook to. But you need a way for this nitrogen to escape without building up pressure. Otherwise, as you go to braze this, it's going to explode in your face. So we're going to do the same thing, and we're going to use the same brazing rod we just used. And you can see I didn't use much of it.
and we're going to connect this pipe. The torch went out because I hit the knob with my palm. Alright. So we're going to let that cool. And then I'm going to wipe down the top here to get all this oxidization off the top here. And then we'll bang it just like we did. And we'll see if anything comes out of there. Okay, so I just took a piece of sandcloth and very lightly went around the outside, just to make sure whatever we get out of this is coming from the inside of the pipe and not the outside. So, you do just like we did before, and you can see nothing came out of there. No dust, that mark is from the outside of the pipe. But you can even see, I don't know if you guys can actually see in there, probably not. I don't know if you can see inside of there. You see nothing there is coming out of that pipe. You know, tiny few marks up on there that came off, but I think that busted off the top of this, not the inside of the pipe. But either way, you can see how the difference between that and what I just did. Now you have the same problem with this, in that you can bend it. Okay, so now we're going to silver solder this valve from steel to copper. So we want to clean up the copper, which I've already done to this piece here, and we want to clean up the inside of the fitting here. And do my piece of sandcloth, just went somewhere. And we're just going to give the outside here a quick clean. Now this is a valve, and when you get them, they're front seated, meaning that the pad in here is all the way up to the top. So what we want to do is take it and back that off. Okay, so now even though this is a form of brazing, we need a flux. So it's a white paste flux, and this stuff is almost past its due date here. And just like before, we only need a little bit of a skim coat on there. Not much at all. Now you can see this is the same as regular soft solder. And we're going to put it in. And I like to give them a little twist, and that kind of spreads the flux out, and also gives a nice little bead around the top of the flux. Now when we heat this up, let me just tighten this vise. When we heat this up, the copper is able to conduct heat better than the steel. So the copper is actually going to wick away a lot of the heat, and the steel is going to get hot first. We want them to get hot at the same time, the same temperature, the same color cherry red around the same time. So what we want to do is concentrate our heat on the copper first until that just starts to get turned cherry red, and then we'll move our torch down and put our heat on the steel, and that'll heat up right away and get nice and cherry red, and then we can touch the silver solder in. Now as compared to braze, this stuff tends to flow a lot easier, be a lot more liquidy when you heat it up, almost like soft solder, but it still is a form of brazing. So the same thing applies with the nitrogen flow. You want to flow nitrogen through this. So let's start heating it up. So let me just make sure everything's in frame before I do that. Which it's not really, but that's a little better. Okay, so we're going to start heating this copper up first and then move to the steel. Okay, you see the solder dried, the flux dried right up there and turned into a paste, really chalky. As I heat it up more, then it'll turn into a liquid again. And you can see it start to bubble and liquid up, and you can see where the flux is working. Alright, that's just starting to turn red. I'm going to move my heat down to the steel. And that's going to heat up. You see that start to turn cherry red? And they're all nice and red together. And then we're just going to cut. And you can see that flowed right around. Come to the other side here. Cut. And that's it. Your joint is done. So I'm going to let that cool off. And then the same thing applies to soft soldering. You want to wipe that flux off. You got to get that off. Otherwise that'll turn the copper green also. So, and you can actually see where the flux worked. See the nice shiny copper here and the dark kind of dingy copper over there. Now, you can tell what they use to connect the pipe with. You can't necessarily differentiate phos copper from the 15% silver or things or anything like that. But I've never had a problem using the phos copper even over any braze that I've encountered if you had to. Obviously you want to go with the same thing that they use. So I cleaned this up and you can see it's kind of a copperish color, whereas this silver solder is a nice gold and the soft solder here is a silver. So you can see the difference in colors there. And we'll go over all this on the bench also. So let's just let that cool down and then we'll go right over to the bench. Okay, so let's take a look at our joints here. And we'll start off with just the last one that we did. And this is our copper to steel joint. And you can see we cleaned up to about here. You can see the scratches from the sandcloth. Even though we cleaned it with the sandcloth, we didn't get put flux up here. So you can see it's nice and shiny and clean here, but then you have a demarcation line of the oxidization, and that's where the flux wasn't. So all this shiny spot here is where the flux was. You can see we're nice and sealed all the way around. That is just a flux mark, that's not a hole. You can see it comes right off. And you can see that nice kind of gold color that'll differentiate it from other forms of connecting pipe. So let's take a look at our soft solder joint, and you can see, if I can get it to focus, sorry about that. You can see here is the little bubble, and you can see, so that was on the bottom, and you can see we're nice all the way around. So it was in this orientation here, we heated up, hit it once right here. You can tell because I was a little off with the solder. You can see how it hit here and rolled in, and it got sucked in. Now if I turn it this way where I cut it, I don't know if the camera will pick it up, but you can see as I was cutting through, you can see little flecks of silver. That's where the solder penetrated. It penetrated all the way around, but that's just where the teeth of the saw didn't match the copper over, and you can kind of see that the way it worked into the joint, and that's about a ½ inch into it. Now let's take a look at the inside of the pipe. So here's our cut-off piece, right? Here's that little demarcation line of the coupling, right? So that's where the two pieces meet, and you can see the two halves meet right in there. All right, and you can see, I don't know if the camera will pick this up, but you can see the silver all the way down to the end here. I don't know if the camera will pick that up. And you can see the copper in there is nice and shiny and clean. And the best part is, you can see there's no flux in the line. Right? You see that? See how there's nothing? There's nothing in the line. There's no kind of gooey pieces or anything in here, so the flux didn't even make it inside the pipe. So people saying that flux contamination will kill the system, if you do it right, you don't get flux in the system. Alright, so now let's take a look at our first braze joint, which is the 7/8 piece. And you saw how it weakened the copper, how it turned this soft, and I can actually bend it by hand. And you can see, as compared to, say, this joint here, just how much uglier it looks. I mean, this looks ugly, okay? And you can see that the brazing rod wanted to follow the flame. Wherever you put the flame, it kind of traveled with it. Alright, so you kind of, instead of this nice little line, like so, all the way around, well, this is actually better demonstration here, nice little line of solder all the way around that's at most here, maybe a little over 1/8 inch out, and that's the bottom. You get this giant kind of swath of braze over everything where the heat hits. Now the problem, the worst problem with this is if you don't heat it up enough, and I'll show you the inside of it. Here's the inside cutaway. If you don't heat that piece up enough, right here, if you don't heat this up enough, unlike the soft solder, which traveled all the way down into here, it's only going to seal around this outside joint. So it's only going to want to seal around this very, very outside, and it's not going to travel down and penetrate in if you don't heat it up enough. But I can see traces of it. I don't know if the camera will pick it up. Traces of it here, all the way down to here. You can see black marks. Now you can see how dirty it looks inside compared to soft solder. And this, actually, let me get something white. So you can see without the nitrogen, you can see how oxidized and how nasty this stuff is. And now this stuff is all flaky, it's loose. You saw how much banged out when I banged it against that piece of wood. This will all come out eventually. I can rub my hand on there and you can see it rubbing off, right? Now let's take a look at the nitrogen purged. Lot of difference there. Lot of difference. Look at the difference. You have some oxidization here, but if you look at it, it's impurities being burned out of the copper itself from heating it up. It's just like heat marks. It's not oxidization like this, all right? And I can't. You can see here's nice white cloth. You can see it doesn't want to flake off. And this here, I can see the remnants of the braze joint all the way down and in. But you can see the difference in why you need to use the nitrogen purge. You can see the difference in the copper there. Okay, so you can see the difference here. We have the Stay Bright number 8 with the Stay Clean flux here. We have the regular Dynaflow Phos copper sticks with nitrogen purge, without nitrogen purge, and your 45% silver solder with Stay Sil flux on a copper to steel joint. So each one of these products has its uses, but my go-to thing for connecting any refrigeration pipe is always going to be the Stay Bright. I mean, this here is just telling as to why. And like I said, as far as fatigue, heat, or using it on discharge lines, I haven't had an issue with it at all. I urge you to at least try it, give it a shot, and see how you like it. Try it on one of your systems, a non-critical system, and see how you like it. It's definitely a very, very good product, and it's my go-to way to join refrigeration tubing. As you can see, if it's done correctly, you don't get any kinds of flux or anything into the system. I mean, this is a normally accepted way of connecting pipe, and you use flux with this, but nobody ever screams system contamination with this flux, but for whatever reason they do with this. And I think a lot of it is just a whole lot of misconception, and a lot of it is they think that this is quicker because they don't have to clean the pipe. My normal go-to method here, I'll use this when I have to re-braze something, obviously, or bridge a really big gap, or where it's indicated by the plans where they specifically request this. That's the only time that I will use the brazing rod. And obviously any time that I have a copper to steel joint, I'll use the 45% silver braze. So you have a ton of options out there, but definitely look into, if you haven't already, look into Stay Bright. And I have used this on 410A and I haven't had an issue with it. So I know some people out there are going to disagree with me, and that is perfectly fine. A lot of people are set in their ways, and there's 1,000 ways to do this trade, but in my experience, like I said, 16 years of doing it, using Stay Bright since I was first introduced to it when I started working for my company, and haven't had an issue with it since. And no matter what, any joint that is not joined correctly will eventually leak, whether it is soft soldered, brazed, or silver soldered. I mean, you see some really nasty joints out there. I think that the biggest problem people have with soft solder, if they're used to brazing, is overheating the pipe. And the biggest problem that people have with brazing is not heating the pipe enough. A lot of times, you can see how this flowed in nice. It's relatively, except for that little guy there, it's relatively smooth. A lot of times you'll go there and see just globs everywhere, and that tells me that they didn't heat up the pipe enough. And joints like that will leak eventually. And also, this brazing rod works good on dirty pipe. If you have to fix a leak on a system where the tubing is pitted, which happens, you have to save the system, save the leak, or fix a leak. Usually the only way to get past that is with braze. It won't get clean enough to use Stay Bright. But if the copper is in any kind of decent shape and you can sand it and clean it, even if it has a few pits here and there, you can use the Stay Bright on it. So I mean, the choice is yours. And like I said, I know some of you guys are gonna vehemently disagree with this, but in my experience, what you see here is what I come across. So thanks for watching this video. Hope you guys like it. Sometime next week we'll probably have another beginner video choice up. We'll come up with some ideas and make a quick video on that. So thanks for watching. See you on the next.